In a traditional classroom, we teach the theory first and then ask students to apply it. Problem-based learning, or PBL, asks you to reverse this. You present the broken machine first and let students figure out the math. By the end of this video, you will have a complete step-by-step blueprint to take one of your standard upcoming lessons and build it into a dynamic problem-based challenge. The mathematician Seymour Papert argued that traditional education gets the sequence backward. He believed students should start with practical engineering and abstract out the physics and math from that physical experience. Grab a piece of paper and divide it into 5 sections. Write down one mandatory curriculum topic you need to teach next week. We are going to map it out together, step by step. Flipping the chronological sequence from theory first to problem first re-engages student curiosity by giving the content immediate utility. Students engage because they actually need the information to accomplish the task in front of them. For Section 1 of your planner, you must seed a fraction of classroom control. Identify one minor daily routine, like how your class lines up or updates a birthday chart, and ask your students to solve the logistics of it. Section 2 is the backwards plan, asking 3 questions. What standard must be learned? What interests your students? And what problem connects them? For example, combining history with a student interest in building leads to a physical challenge: design a water wheel. You ground this abstract design by studying the historic Saugus Ironworks. Seeing centuries-old technology in a physical location validates their engineering choices. Or, if teaching geometry and surveying, task them with determining the logistics of building a massive metal bridge across a muddy river in their town. The authentic community context acts as the bridge. It connects mandatory, abstract curriculum directly to genuine student investment. In Section 3, do not present the problem as an assignment. Frame it as a mission, applying the logic of game design. Game designer McGonigal argues that games are specifically engineered to make players better at solving complex real-world problems. This comparison shows the difference. Instead of a standard textbook prompt like, write an essay on deforestation, you issue a mission objective: design a strategy to save local green space. This gives the students a clearly defined win state. This mission strategy aligns with how younger students already operate. They are wired for gaming mechanics and tend to prioritize goals like environmental sustainability. Applying this logic bypasses typical academic fatigue. You trigger the psychological drive to solve puzzles and achieve clear victories. Once the mission launches, use the KWI framework in Section 4 to organize the investigation phase. Set up a board with 3 columns. Start with K, what do the students already know about the problem? Then W, what do they need to learn to solve it? Finally, fill in the I column. What ideas do the students have to reach their win state? To answer the questions in that middle column, have your students identify and contact local industry experts, such as city planners or programmers. They can also investigate primary sources directly. By analyzing physical, historical environments, like settler huts in Jamestown, students evaluate missing perspectives in the historical record. The KWI framework shifts the classroom dynamic. Students stop waiting to receive curated information and start directing their own research. For Section 5, your final planner entry, define 1 to 3 potential products, but commit to keeping the format flexible. Whether they make a poster or a formal presentation, the format is merely a vehicle. The actual goal is solving the problem and mastering the underlying content. This chart shows how adaptation works. Your initial plan might be a website, but based on their KWI research, students might propose a podcast, a physical prototype, or an app. You have to adapt to their trajectory. Sometimes a lesson will flop. That failure is an expected part of the process. It simply signals that you need to reteach a specific concept. Prioritizing a working solution over a rigid format helps students build academic resilience. It mimics how problem-solving actually works outside the classroom. Look back at your completed planner. You now have the 5 components needed for a launch: a routine handoff, a backwards plan, a game logic mission, a KWI structure, and a flexible finish. Remember to normalize the flop. Treat dead ends as opportunities to iterate rather than educational failures. Your first test starts tomorrow. Go to your classroom and ask your students to solve just one minor, non-academic problem together. Shifting to problem-based learning alters your lesson plan, and it reallocates the authority to solve problems to your students.